Good morning or good evening, wherever you are. Welcome to Kasyanno, EZMath. We have here mastering how to solve constant motion word problem. And we have here formula S is VT and the other one is D is RT. And we have a big word right here from the word master. That means after this class or after this lecture, you can be a master. You can do it by doing investing more time in your practice in solving problem. That's the same way in solving this constant motion word problem. Constant motion means the speed never varies. That means all throughout, let's say you started out with 25 miles an hour, it can be all the way 25 miles an hour until the end, from the start to the end of the travel. And we have formulas over here: SVT and these are T. S stands for distance, V stands for velocity, and T stands for time. But here in algebra, we just refer to it as rate, since velocity, in a sense, in mathematics is a definition which consists the speed in relation to its direction of the speed. And drt is simply the distance is equal to rate times time t. So in here we can do interchangeably use this formula over here. Distance S is vt or d is equal to rt. It's about the same. So all we have to do though is make this v velocity as a speed. Since we're covering mastering how to solve constant motion word problem, we need more practice in doing how to solve constant motion word problem involving rowing or boating or paddling on a river or on a stream going downstream and upstream. Motion problems like this, you need to consider the speed of the water current and the speed of rowing or paddling. This is applicable also in solving a motion problem when it comes to airplanes covering a distance over a period of time in relation to the effect of the speed of the wind. So, and this formula is also applicable to solving problem when it comes to speed on land, vehicle speed, like car speed. Okay, so constant motion, that means the speed never varies, it never changes. So from the word master again, mastering a skill is to put an investment in terms of time solving problems, since practice is essential in achieving mastery of any skill. Mastering this math skill, you would know what to do. Let's practice. So let's do this practice. All right. So here's our problem number one, the statement of the problem. A rower on a kayak with a speed of 1.25 miles an hour on still water takes 2 hours rowing downstream from point A to destination point B. Rowing upstream takes the rower 3 hours from point B to point A. Find the speed of the stream and the distance between point A and point B. So here's the illustration of the problem. Based on this illustration, there's a guy rowing the river, and if you notice, from point A to point B, and this designates or indicates the river, and the flow is going downstream, since the water flows towards the lower portion, to the lower side, from the upper side to the lower side. And here, the given here is vis-a-vis. That means the speed of the rower, the speed of the guy on the boat with paddling the boat, vis-a-vis is 1.25 miles per hour. That's going downstream, and the speed of the stream is unknown. That needs to be found out. And time travel from upstream towards the downstream is 2 hours, but going back is the flow of the river. It takes the rower 3 hours from point B to point A, since it's going through against the flow of water on the stream. And this speed right here, vis-a-vis, is determined by the rower on steady water. that he determined his speed is 1.25 miles per hour. Now we need to find for the speed of the stream, vis-a-vis, and the distance of travel from point A to point B. So as illustrated in the problem, we have to find these two unknowns right here. So in order to solve this problem, you have to have two equations to solve two variables. All right, that's the principle on that. So in solving the problem, there are two ways to solve. One is by using tables, and one is by doing substitution and elimination. All right, what does it mean by that? Doing a table, that means we tabulate all the contents of the formula. S is Vt, or distance straight times time, and those is speed of the current, tabulating all the speeds, speed of the rower, speed of the current, and going downstream and upstream. And the faster way to solve the problem is tabulating the given. All right, so now we have a table over here representing all the variables and all the values of the formula. Distance is rate times time, and we are considering the downstream and the upstream. Now we're considering the downstream. We have the speed of the rower, that's 1.25 miles an hour, and time going downstream, that's 2 hours to complete the travel from A to B. So in here, so distance is D, is unknown, so we still have to put D right there. And then the rate downstream is the sum of the speeds, or the rates of the stream plus the speed of the rower. So that means vis-a-vis plus the speed of the stream, vis-a-vis, and multiplied by time. How much time needed to complete the travel A to B is 2 hours. That's 2 hours. And considering upstream, traveling going back, that means going against the flow of water on the stream. So that's distance again, the same distance covered. So this D, and the rate is the rate of the rower minus the rate of the stream, since it's going against the flow of water or against the current. So that means the speed vis-a-vis, now since it's going against the current, that's minus the current rate, the rate of current, that's minus vis-a-vis. And they're covering how many hours for that travel from B to A is 3 hours. So that's 3 hours right there. So now looking at our table over here, downstream and upstream, we have two variables, vis-a-vis, speed of the stream or the rate of the stream, and the distance of travel. Since we know the value of vis-a-vis, the speed of the rower, that's 1.25 miles an hour. Vis-a-vis and D, we have to have two equations to solve two variables, right? That's the rule. Okay, so first equation, where could we find that first equation? So out of this right here. So first equation is from the traveling going downstream. D is equal to vis-a-vis, we know vis-a-vis, that's 1.25 plus vis-a-vis multiplied by 2. So since distance is rate times time, so that's 2 hours. So we can make that as our first equation now. The second equation we'll be considering upstream. So the upstream travel is D again. D is equal to vis-a-vis, that's 125. Since going against the flow, that means you subtract the rate of the current, that's vis-a-vis, and multiply by 3. Since time is 3 times 3 hours travel going back against the flow of the current. So that is our equation 2. Now we have two variables, vis-a-vis and D, and we have two equations, so we can solve the problem. All we have to do now is equate these two right here. So 1 and 2. So equate them together. We just multiply them together, or 1.25 plus vis of s times 2 equals 1.25 minus vis of s times 3. So from here we can solve the value of vis of s already. Right? Because we have just one variable now, vis of s. And by using your calculator, we can do vis of s is equal to, that's 0.25 miles per hour. That's the value of vis of s. Okay, so we found vis of s already. And what we do now is just substitute the value of vis of s to either equation 1 or equation 2. So if we do it on equation 1, we're going to have that to here. D is equal to 1.25 plus vis of s, 0.25 times 2. So therefore, D is equal to, so 1.5 times 2, that is equal to, so D is equal to 3 miles. So we found the solution for this problem already. So we found the vis of s, the speed of the stream, 0.25 miles an hour, and the distance of travel is 3 miles. So we're on problem number 2, the statement of the problem. An airplane with a tailwind, assuming constant speeds, can fly 2,000 miles in 2 hours from point A to destination airport point B. The same plane flying back against the wind from point B to point A takes 3 hours. Find the plane speed and the wind speed. So here's the illustration of the problem. Now we have problem number 2. This about air travel. That means it involves airplane and the speed of the wind. So in the illustration problem over here, from point A to point B, we have an airplane traveling towards point B from A, and we need to find out the value of the rate of the speed of the airplane and the speed of the wind. The direction of travel is the same as the direction of the wind. And going back from point B, airplane is going from point B to point A, with the plane traveling against the direction of the wind for 2,000 miles. And then the travel time from point A to point B is 2 hours, and travel time the airplane from point B to point A is 3 hours. That means you get more time to cover traveling back to point A. The travel distance is 2,000. That's 2,000 miles. And now we need to find the rate or the speed of the airplane and the speed of the wind. So now once again we have two variables, vis of B and vis of A, and we need to find two equations to solve these two variables, right? That's the rule. And as I mentioned earlier, there are two solutions to this problem by doing a table, by drawing a table and tabulate all the given part of the formula, and the other one is by substitution or elimination. By using the table, it's the same way as boating on the stream or on the river on our first problem, the problem number 1. So if you're going, it's like you're going the same direction with the wind. That means you're adding the speed of the airplane to the speed of the wind. On problem number 1, that's the same thing, the speed of the rower plus the speed of the stream. And going back against the wind is like going upstream on the first problem. And here the plane is going against the wind. So we have to subtract the rate of the wind or the speed of the wind from the speed of the plane. So that's the same way. Now, so in this case, since we have done the tabulation already in the first one, we have an option to solve the problem by elimination or substitution, we call that. Now, since we're solving this problem number 2 by using elimination and substitution, now we consider the travel of the airplane from point A to point B. So we use the formula, the same thing, S VT, where S is the distance, V is the rate, and times T. So we do that from point A to point B. That means distance is 2,000 miles is equal to the speed, that's v, speed of the airplane, plus a speed of the wind or a speed of the air, v sub a, times time of travel from point A to point B is 2 hours, so that's times 2. Okay, so that's we can simplify that also as 2,000 equals 2 v sub b plus 2 v sub a. That should be our equation 1. Now to formulate equation 2, we have to consider the travel of the airplane from point B to point A. And we don't know both speeds, but we know the time. Time travel took was 3 hours from point B to point A. So consider point B to point A travel. Okay, so we'll be doing again. So 2,000, we use the formula SSVT again. Distance is 2,000. 2,000 miles is equal to v sub p, speed of the airplane, minus the speed of the wind, since the wind is against the direction of travel. So times t, where time t is 3 hours. So we have here the distance is 2,000 equals, we are using this formula right here, distance is equals to vt. So speed is speed going from B to A. The direction of travel is going against the direction of the wind. So Vp minus Va times 3. Since the time travel going back from B to A is 3 hours, times 3. Simplify it further, 3 times Vp minus 3 Va. That should be our equation 2. Now if we take a look at equation 1 and equation 2, we have 2Vp, 2Va, and here 3Vp, 3Va. All we have to do is take a look at the coefficients. 2 here and 3 here. Or the same thing, 2 here and 3 here. What we have to do now is to simplify this and it makes it easier in doing elimination. Since the coefficient of equation 2 is 3 over here, we multiply this by 3. All equation 1 by 3. On equation 2, we multiply the whole thing with the coefficient on that 2. The whole equation multiplied by 2 and the whole equation multiplied by 3 on here. So all we have to do is rewrite those equations and solve the problem. So equation 1 times 3, that is 6,000 equals 6 Bp plus 3 times 2 is 6 v sub a. And equation 2 multiplied by 2, that means 2 times 2 is 4,000, equals 2 times 3 is 6 Vp, and then 2 times 3 is 6, that's negative 6 v sub a. And if you take a look, these two equations, and all we have to do now is, since if you notice the sign right here is positive and negative right there, that means if you add this up or subtract, we dissolve Vp, we're gonna have Va. If we add, that means we're dissolving Va, but we have variable Vp either way. So let's do add that. So 6,000 plus 4,000, that's 10,000, equals, this cancels out, and then 6 plus 6 is 12 Bp. Okay, and now it's clear that the P, the speed of the airplane, is 10,000 divided by 12. It's the speed of the airplane. Now, since we got the value of the speed of the airplane already, all we have to do is simply substitute this one to either equation 1 or equation 2. So either one. Which one is simpler? Either one. So we use equation 1. It's 2,000 is equals 2Vp plus 2Va. So we use equation 1. So this 2, equation 1, we use that one. So from equation 1, That's 2,000 equals 2 times v sub p. That's 10,000 divided by 12 and plus 2 v sub a. 2 v sub a. And when you got simplify, this 2 over 12 is 6. And we do v sub a. V sub a is equals to 2,000 minus 1,000 over 6 all over 1/2. This coefficient of v sub a is 2. Okay, we simplify further. So that is 6 times 2,000 is 12,000 minus 10,000 over 6 times 1/2. And v sub a is equal to 12 minus 10. That's 2,000. That's 2,000. 2 minus 10 is 2,000 divided by 6 times 1/2 is equal to 2,000 over 12. 2,000 over 12. So v sub a is equals, by using your calculator, you can compute the value of that now. 2,000 over 12, that is 166.666. That's miles per hour. And from here, values of Vp from earlier is 10,000 divided by 12. Is from earlier. This is 10,000 divided by 12. That's 833.33 miles per hour. Bar right there, that means these digits are being repeated all over, non-ending. It's a non-ending repeated digits, 33. Okay. The speed of the wind is 166.66 miles per hour, and the speed of the airplane or the plane is 833.33 miles per hour. Okay, that's the answer. So far we have solved 2 problems. One concerning travel on water, that's boating or in stream, it's on water, by using tabulation on that one right there. And problem number 2, air travel, where we used elimination substitution method. So we are now on problem number 3. Car A starts traveling with a speed of 45 miles per hour from point A to point B. An hour later, car B started traveling from point A to point B. Assuming both cars have constant speed, find the speed of car B if both cars reach the destination point B at the same time, and the distance point A to point B is 120 miles. So here's an illustration of the problem. Now we are on problem number 3, the application of this formula on land travel. That means traveling on land using our car, any vehicles moving on land. So SVT, the same way, we have the same formula. And now the illustration of the problem is this. Car A starts traveling from point A to point B, and with the average speed of 45 miles an hour. And after 1 hour of travel, car B started traveling with undetermined speed or velocity, or we do it speed over here. And that's after 1 hour. That's after A. So the distance of travel is 120 miles to point B. And the condition is that car A and B reach the destination point B at the same time. But then car A started 1 hour after car A started traveling towards point B. So we need to find out the value of the speed of car B. That means car B is faster than car A, since there is the same destination, point B, even though he started 1 hour later compared to car A. Alright, so let's do that. Since we have already used the table earlier, we can do table over here again, or substitution, either way. Well, the aim of this lesson is mastery. So probably we can use table or both substitution. All right, let's do that. Now we're using a table to solve this problem. So we're tabulating the values of those variables in the formula. We use D is RT, distance, rate times time. Okay, so consider car A. The distance traveled is the same. It just so happened that car B started 1 hour later than car A. That means car A traveled the same distance as car B. So distance traveled is 120 miles. And the rate of A is 45 miles per hour. And the rate of time is, we don't know the time, do we? We don't know the time. And now car B is traveled the same distance. So distance 120 miles. And the rate of the car B, we don't know. So that's V sub B. The speed of car B. And time, we can actually solve what's the value of T now. To travel a distance of 120 miles with the speed of 45 miles an hour, we can calculate the time. Since the formula is D is equals to RT, get the time is equals to D divided by R. So that means this is 120 distance divided by rate. So 120 divided by 45. And car B, since car B started an hour later, that means he got lesser time, 1 hour less time than car A. That means we have the time of car A over here already. That means 1 hour less than this. So that means 120 over 45 minus 1 hour. So that's the time of car B. Now, since we have just one variable, V sub B, we can solve the problem now. By using car B alone, we can formulate an equation out of that. So from here, it's 120 equals V sub B times this one right here. So let's just do that as a parenthesis instead. Times 120 over 45 minus 1. So V sub B. Okay, so this simplify further. V sub B equals 120 minus 45 over 45. It's equal to, so V sub B is equal to 120 divided by this. So 120 minus 45, how much is that? That's 75. That's 75. That's 75 over 45. So that will be equal to 120 times 45 over 75. So V sub B is 72 miles per hour. So that's our answer. So we have just finished our lecture on mastering how to solve constant motion word problem. Once again, from the word master. Now, being a master, it lies in your hands how to become a master. That means you need more practice in solving constant motion word problem, so you gain mastery of this skill in solving. And now we just finished all these 3 problems, and we presented 2 solutions in solving the problems by doing a chart, or we call a table, and the other one by doing substitution and elimination. So I hope you guys like this video, and if you do, don't forget to hit the like button or subscribe button. Thank you for watching. And if you are a math student or a person trying to learn or relearn math or algebra, I encourage you guys to subscribe to my channel so you will not miss any of my algebra or math videos uploaded in the future. Since I'm regularly uploading on a weekly basis algebra course lessons on YouTube, same way on related videos on math mastery and problem solving. Thank you very much, and hope you guys have a great day.